Welcome back. So you've already done 7-1 part 1, 7-1 part 2, and 7-1 part 3 is where we wrap it all up together. So you did the notes in 4 parts. I had my students take one clean piece of paper and fold it up into 4s. And the first video did box 1 of the notes. The second video did boxes 2 and 3 of the notes, and this video is doing the last box, aka box 4 of the notes. So let's check it out. So box 4 of your notes is all about putting all of this together, all of the stuff that I've taught you, and to simplify exponential expressions. So let's look at the title. So simplify expressions with negative and 0 exponents. Perfect. Let's look at our first example. So we have 3x to the negative 2, y to the negative 2. Okay, so we have some negative exponents up there, and we have a 3 with a positive exponent of 1. Remember, if we don't see the exponent, it's an exponent of a positive 1. So I'm going to look at each one of these, and I'm going to check it out. So it's in the upstairs apartment. I have 3 roommates that live in the upstairs apartment. I have 3. I have X for Xavier, and I have Y for Yahir. So I have 3 people that live in the upstairs apartment. And I need to simplify this. A simplified expression means there can't be any 0 exponents and there can't be any negative exponents in my final answer. So I know this is not my final answer because I clearly see that there's some negative exponents. So let's clear this up. So I'm going to go up to each one of the 3 roommates and say, hey, would you like to stay or would you like to go? Hey, 3, would you like to stay? Oh, Teresa, I'd like to stay. He has a beautiful positive exponent, and if you have a positive exponent, you stay, which means he's going to stay in that upstairs apartment, also known as the numerator, right? X to the negative 2, aka Xavier. Xavier, would you like to stay or would you like to go? He's like, nope, I'm unhappy, I would like to move. And that negative exponent is the giveaway. So I'm going to grab Xavier, move all of his stuff, and move him to the downstairs location. And that's where he turns into be a happy camper. He's an X to the positive 2. Remember, when we move from the up to the down, it changes the sign of the number. Yahir is also unhappy. So he already lives in the upstairs apartment and he's unhappy. So we need to move him to the downstairs apartment. Boom. This is my final answer. Why is it my final answer? Why is that my simplified answer? Because I don't see any negative exponents and I don't see any exponents of 0. Done. Okay? You try one. This one's a little spicy, I'm not gonna lie. This one's got some spice to it. That's also a roommate situation, so I like to draw that vinculum, the fraction bar line, and I like to put a 1 downstairs. And then I'm gonna check out all the exponents. If I have a missing exponent, I know it's a positive 1. So there's my 3 roommates. They all live upstairs. Maybe some of them want to move. I don't know. Check it out. You guys try this one on your own. You can pause the video, and then we can check it out together. Let's give it a try. So I'm going to go up to each one of these roommates, and there's 3 roommates, negative 4, X, and Y. Hey, negative 4, yeah? How do you like that upstairs apartment? I love it. I know what you're thinking, but it has a negative, Mrs. Miller. We look at the exponent to determine if something stays or goes. Not that negative or positive in the front, okay? I want to look at the exponent only. And this negative 4 has an exponent of positive 1. If you have a positive exponent, you stay. Oh, well, this is interesting. You might have to go to box 2 of your notes. What was the value of any letter or number that was raised to the power of 0? Do you remember? It was 1. So he's going to stay up top, multiply by 1. This guy is going to definitely move. A negative exponent implies I'm going to take that reciprocal and I'm going to move it. I'll be honest, that's not quite simplified. That's not very attractive. What is negative 4 times 1? What's anything times 1? It's just that thing, right? So we technically can simplify it. We can erase it because negative 4 times 1 is just negative 4. And that, my friends, is your final answer. You guys try one on your own. I'm going to give you one. Here's C. Give it a try. We have x to the negative 3, and we have y to the positive 4. You give it a go. My suggestion, vinculum, the number 1, a little dot, so you see that there's 2 roommates in that upstairs apartment. Go ahead, you can pause the video and you can give it a try on your own. Give it a try. Are you done? Cool, let's give it a try. So the first thing I do is I draw my vinculum. I put the 1 downstairs because that's the only number that I can use to hold that bottom location. I'm gonna go up to the x guy. Should I stay or should I go now? Does x want to stay or does x want to go? The negative exponent is a good giveaway that he wants to go. So I'm gonna take the reciprocal, I'm gonna move him downstairs. And don't forget to make him a positive. Cool. Hey, y, does he stay or does he go? Remember, if you have a positive exponent, you stay. If you have a negative exponent, you go. Ah, he's got a positive exponent, so he's gonna stay. And this is our final exponent. Do we see any negative exponents still? Nope. Do we see any 0 exponents? Also nope. That is our actual final answer. Cool, you guys try another one. Here's D. You guys give this one a go. Ooh, that's a very interesting question. Give that one a go. Cool. How'd you guys do? Think you got it? Cool, let's take a gander. I like to put the dot there. I like to see the product. It reminds me I have two bits of information up here. I have 2 pieces to look at separately. So I have the X guy. Clearly he wants to move. He's an unhappy camper. And I look at the Z guy. Oh, he wants to move as well. So we took the reciprocal of both. Uh-oh. We must have a space holder on the top. We can't just leave it blank. What's a good space holder? Most kids either yell out 1, 0. One of those is the option that we have to go with, and that would be 1. Cool, good job. Let's look at E. E looks like a doozy. Oh, shenanigans. We have a lot of people that live upstairs. We have A, we have Z, we have Y, we have X, and we have something hiding. Visual learners, what is it? Do you see it? Yep, it's a -1. So technically we have 1, 2, 3, 4, 5 roommates upstairs. The -1 has a positive exponent, the X has a negative exponent, the Y has a positive exponent, and Z and A both have a negative exponent. You go ahead and give it a try. What is it going to look like when you simplify it? AKA, your final answer can't have any negative exponents or 0 exponents. Go for it, give it a try. Wait. You think you got it? Cool, let's try. Can you guys see over there? Yes. -1, stay or go. Now remember, don't look at here to determine if it moves. We look at the exponent. A positive exponent stays. A negative exponent moves. He's definitely a stay, good job. Did you say go? Nice. Stay or go? Nice. It's a stay. How about Z? Stay or go? I hope you just yelled out go. And how about A? If you said go, I agree. Let's look at our final answer. Are all the exponents positive? Check. Do we have any zero exponents? Nope. That is the simplified version of our answer. Miss Miller, can I put the negative just out in the front? Yes, you could do that as well. Some kids might not even write that. They literally might do that. And that's acceptable as well. Okay? Kind of just depends on your personal preference and how you see things. But both mean exactly the same thing. So it's either pick one or the other, whatever floats your boat the most. Are we good? Cool. The last one. We got the chupacabra of mathematics here. Go ahead, give this sucker a go. If you can get this one, and there's nothing remotely like this on your homework, obviously. This is just a crazy one because Mrs. Miller, cuckoo, is just having fun with you. So give it a go. If you can get this one, you got this. So go for it. Give it a try. It's 10x to the negative 2, y to the 0, z to the positive 3, a to the negative 4, and b to the positive 2. What do you think it's going to look like? Give that one a go, okay? Give it a go, yeah. I'm going to erase this so I have room to do that one. And this is our last question. And you should be totally ready for the homework. And if I'm not mistaken, I think I put the answer key on. You can double check your own work too. So we have 1, 2, 3, 4, 5, 6 roommates that live in that upstairs apartment. Wow, that's packed. No wonder some of them are unhappy. So we have 10 to the positive power. Stay. We have x to a negative power. Go. Ooh, you remember what that guy is? Anything to the power of 0 is 1. But if I put multiply by 1, what is 10 times 1? Just 10. So we don't need to show it. It didn't change anything, but we did acknowledge it. How about 0 to the positive, how about z to the positive 3? Stay. How about a to the negative 4? Go. And how about b to the positive 2? Stay. Let's make sure that is our simplified answer. Do we have any negative exponents left? Nope. Do we have any exponents of 0 left? Nope. We have beautifully and very effectively simplified that one. Good job. We're done with this video. I'm proud of you for keeping up. Have a great day. Bye.